Dear students, greetings from Dr. T. Sendil Murugan, Associate Professor and Head Department of Information Technology, Faculty and Staff Technology and Science, Warangal. In this video lecture, we are going to discuss about memory allocation and deallocation of linked list concept. After creating the node at the time of execution, how we can allocate the memory, how it will be deallocated. Those concepts we are going to discuss in this video lecture. This is week 8, lecture 2, classroom discussion topic 23. We are going to discuss about memory allocation and deallocation for the linked list. So before starting this lecture, we must know the lecture outcome of the particular lecture. After completion of this lecture, students will be able to develop a C program to create the nodes in the linked list and allocate memory at the time of execution. Okay, at runtime, you have to allocate the memory, and after using that memory, we can free the memory or deallocate the memory. So both it will be able to do by the student. Memory allocation. We know how the linked list represented in the memory. So like the start pointer will be there. Then after that, the start pointer have address of first node. This pointer is pointing to the first node of the linked list. Each node have two portions. One is the data portion, another one is pointer portion. This pointer is pointing to the next node where it is stored in the memory. So here, this is the data part. Again, this is the pointer to next node. When the pointer of next node equal to null, so that is the last node. Null we can represent using X symbol. So this pointer have null means that is the last node of the linked list. If we want to add a node to an already existing linked list in the memory, we first find the free space in the memory and then use it to store the information. Okay. So we already know the memory will be allocated randomly. Okay, it is not sequential memory allocation. So array used as sequential memory allocation. Okay, whenever we are using array, if we are declared array of 5 means the 5 memory location will be allocated continuously or sequentially. But in the linked list, it is not like that. Wherever the free space is there that memory will be allocated, and each memory will be have the link of next space. Like that, if we want to create a new node in the list, we must create the memory space. That means we have to find where the memory is free. So for that, we have to identify like that. You just see here. This is the student linked list. Okay, student linked list example. So with this shaded boxes is there, no? These are the free memories. Okay, so you assume that these are the free memories. Already the remaining parts are occupied. So these numbers is there, no? These numbers are addresses of the particular location. You consider like this. Okay, so address, the operating system will allocate the address of each location. When the program is compiled or executed, the memory will be allocated, especially the linked list using runtime memory allocation. Okay, so that is dynamic memory allocation. We know we have 3 functions to use dynamic memory allocations, like MLF, CLF, and ReLF function we are using for allocate the memory for linked list. So this example especially showing that the student mark list is there in the first diagram. In second diagram, we want to insert one more student list where we are inserted. So here the fourth location is the memory space is free. Then the fourth place is allocated to the last student S12. Okay, so in this lecture. So already you know how to store it. Initially, that roll number, marks it is stored. These two are the data item. and next one is the pointer where the next node is stored. Okay, so here you see that the next node is 2. The 2 have student 2. Student 2 have the next student is stored in the 3 address 3. So SO3. Then next is stored in the 5. So like that, uh, it will be allocated up to S11. When it is comes to S11, it is have null pointer. This is the last node. If you want to add one more student, like S12, we want to add, where we have to add? There is a question mark here. So then the compiler will find, or operating system will find where the memory is free. So here you see address 4 have memory free. So then it will allocate that S12 student with the mark in last node, and last node mentioned as -1. That is null pointer. So after install that assign the memory for new node, then we can give the link of the next node 4. Okay. So these two are we have to consider. Clear. So how we will find that free space and where we have to store? How we know that? Okay. So for that, how we can identify the free spaces? For that, the operating system will do. We don't want to discuss and think about more uh, about allocate the memory of linked list. The operating system will take care. But even though we must be know how it is handling the space management by the operating system. So see here, the computer maintain a list of all free memory cells. Okay, so it will maintain all free memory cells. This list of available space is called free pool. The operating system will maintain free pool. This free pool have all the free spaces which is not allocated already. Okay. So free pool same how the linked list work with the start pointer. No, same like that. The free pool will work with avail pointer. Okay, the avail pointer is pointing to first free location where maintaining the free space or free pool. The free pool, the avail pointer pointing to the first free locations. Then it will like the linked list it is connected, whereas the next free space is there. Like that, it will maintain. Okay. So see this diagram here. Example: the linked list with avail and start pointers. This is the linked list. So what happened? Simply, the linked list they have start pointer. So this start pointer have address of 1. So it will comes to finding the location 1. In this location student 1 and 78 mark is there, then it is finding to the next node. So second node is second student is there. Next third node, third student is there. Next fifth node, fifth student is there. Like that, it will finding up to S11. So S11 finding that -1 in the next node. So -1 means that is the last node of the list. But even we told free pool. So free pool means a collection of free spaces. Okay, so not collection of maintain the free spaces available in the memory. So this collection of free spaces is there, no, that is considered as the garbage collections. Collection of free spaces in the memory that will be stored in the free pool that is considered as the garbage collection. So free pool is there, no, in that in free pool, it will maintain the avail pointers. So avail pointer pointing to location of first free space in the available memory. So in this memory, there is data fields are free. Okay, so here no data, here also no data, but it is pointing to next where the free space is available. So six means the sixth location how free space, next space. Next space it is available in the ninth location. So next space is available in the 14th location. And 14th location have -1. That is the free space also only available up to 4th place. After that, there is no free pool. Okay. So here the avail pointer is pointing to where the memory is available. So if example avail will be set contain address of 6. Okay. So 6 means sixth location is free. So then when we want to insert the new node will be already check the avail space. There it will be added. Okay. So So if you want to delete, when you delete a particular node of the existing list, what we have to do? We have to free space will be there, no? That we have to remove it. That is actually considered as deallocation, memory deallocation. For that, we will use this already free of the memory pointer. If in case we are used the avail pointer, means this we are removing avail pointer, but not like that. We are using this pointer, no? So example PTR, which is created for pointing to the next location or the particular node, that memory will be free. Okay. Then again, this will be added into free pool. Whenever we are releasing the pointer, that will be added into free pool. So what happen in case we are checking that pointer which we are allocated the memory using memory allocation MLF function, we are checking. So PTR not equal to null. Why we are using to check this pointer means, if when we are using that statement, memory will be allocated. But in case of memory is not available, means the particular MLX statements will not allocate the memory, means it is not returning the pointer. Okay, so PTR equal to, we are written that statement now. So this will be written first address of the allocated memory normally. But what happen if PTR equal to not equal to null, means it is assigned some address. If we are, it is null, means PTR equal to null. We are checking this pointer, means what is the meaning? PTR is not equal to null means assigned address. The memory is allocated for the node. If it is null, means the condition fails, means the memory is not available. So the memory we can write it that memory not available. Okay. So whenever we are collecting the free spaces, that is considered as the garbage collections. You know very well. So now we are discussed about what is memory allocation, what is memory deallocation, how it is happened in the system. So those things we are discussed in this video lecture. Now this is the reflections part 1. What is the use of avail pointer? Where we are using this avail pointer? So I will give some 10 seconds time. You just think and tell me. Thank you. So I hope you have written the answer easily, because we discussed multiple times in this lecture. Avail pointer is used to finding the first location of free space, where the memory space available, that is pointing to next available memory space. So in this video lecture, we have discussed about what is memory location and examples of memory allocations, and what is free pool and what is garbage collection. Those things we have discussed in this video lecture. So now as a student, you are able to write the program to allocate the memory and deallocate the memory for the linked list. Okay, so you can use the MLF function and free function to allocate the memory and deallocate the memory for the linked list. You just try to write one program and check it the output. So having completed the discussion on linked list, memory allocation, deallocation concepts, now students should be able to develop a C program to create a nodes in the linked list and allocate memory at runtime. Okay, using MLF function, you can allocate the memory, as well as after using this memory, you can free the memory, like deallocate the memory also. Okay, so you know the concept, you can implement it. So thank you very much for listening this video. In this video lecture, we are discussed about memory allocation, deallocation. Further doubt, you can check with 6.1.3 in Remake Raja textbook. Further doubt, you check weekly tutorial sheet. Thank you very much for listening this video. If you have any doubt, you come with the doubt, we will discuss in the classroom discussion. Thank you all.